Today is the day of the next algorithmic task. And let's take a look what we have. So we go to neetcode, our roadmap, and binary search. And the next task would be the following. Let's revert to defaults and check. Find minimum in rotated sorted array. So suppose that we have an array. It's sorted and it's rotated between 1 and n. For example, we have 0, 1, so it might looks like this and like this. So we have this sorted array of unique elements, and we have to return the minimum element of this array. You must write an algorithm in logarithmic complexity. Okay, so in this case, we cannot just iterate and find it. So let's try to understand. So we have an input as our array. So let's consider what lengths do we have. Can we have, for example, an empty array? I believe that we don't have, so let's say that we have at least one element. And here we have like 1 million of elements. Each element is some integer, so let's say that it's from minus 10 in the 6 and plus 10 in the 6, something like this. And we know that it's unique and sorted with rotation. Okay, so here we have our input, and let's consider some test cases. So for example, if I have 1, then in this case it would be always 1. If I have 0 and 1, so I should return 0. If I have 1, 2, and 0, I should return 0 because, yeah, it's rotated actually. What else? If I have something like 5, 7, 9, 1, 2. So we see that it's rotated in this direction, and I should return 1 as a minimum value. So this test case is quite interesting for me. So let's consider how we actually can solve this problem. Yeah, so let's see that we have such elements actually, and we need to find this one. So so in this case, so for example, when we use binary search, we jump in the middle. So when we are in the middle, we can analyze, for example, left value, adjacent value, and we can see the left one is less than this one. And we can analyze also right value. So if so we have like both cases. So we can have something like this, or we can have something like this. So if we check this 9, and we see that actually left is less and right is greater. So in this case, we can, just jump here, and because we know in no, we don't know actually. So what we need to find, this So in this case, we need to find this place where our next value is less than the previous one. And when we actually find this place, then we can just return this value. But how to find it? In this case, so when we here and we check that the left is less and right is greater, so we can just move our pointer here and try to find it here. But what we can also have, so for example, when we don't have any anything, and we just like 5, so we try to find it here, but we cannot find it here, so then we try to find it on the left. So in this case, we like divide our array in 2 parts. So we can see here, like here if I found it, then in this case we should go right because it's rotated, and in this case we should go actually left. So we have so we have this 2 examples actually. In one example, when we on the 9 we should go right, and in this example we should go left. And in this place we actually cannot determine whether we should go right or left, right? So because but on this place actually we know that every value is less, right? Can it be like I jump here, and can it be like some value would be greater? Let me create maybe some example. Maybe I have something like 10, 9, and then I have like 10, 0, 1, 2, 3, and 7. Yeah, so here is another example. So here I'm 3. Yeah, it's another example. 9. Yeah, so in this case, I should go left. And also, I don't know, right? So, yeah, I don't know. It can be greater or not greater. Let's check constraints. Yeah, it's 5,000. Right. Yeah, in this case, like I should jump in both directions. So, for example, I'm on 3, and then I do binary search here, and binary search here. So it would be L not log n, because first I do like log n here, and actually I have like two arrays, and I should find the minimum here, because I need to find this this point when the next value becomes less over here as well. Yeah, it's interesting, I think, question. I need probably to add it to my mocks further. So how much time already? So 11 minutes. So I think I need some hint. So let's check hint. Array was originally in ascending order. Now that its array is rotated, there would be a point in the array where there is small definition from the increasing sequence. What does it mean? So array was originally in ascending order, and now that the array is rotated, there would be a point in the array where is small definition from the increasing sequence. What does it mean? So for example, if I will jump 7, yeah, I definitely can find this place here. But if I jump 6, I actually don't know whether it's, yeah, so I don't know. You can divide the search space into 2 and see which direction to go. Yes, so I can divide it by 2, but which one? Like in this case, I should go left. In this case, I should go right. And in this case, I should go left. Yeah, so I divide the search space into 2 and see which direction to go. Can you think of an L which has, yes, so it's binary search. All elements to the left of inflection point. Yes. Okay, so for example, 9, I have 5 and 9. So this hint is actually very good. So here I have my point. So I have 9 and I have 5. Here I have 9, but I have 2. So 2 is less than 9, so I should go here. Here I have 3, and 7 is greater than 3, so then I should go here. Yeah, here I have 1. But yeah, here it's interesting, like how I have 7 and I have 9. So probably I should not check this point, but I should check these points actually to understand in which direction I should go. Okay. Yeah, I think it's a good one. So let's think. So for example, I'm here and I check 2, 5. I go to the 2. 3, 1, 7, and go to 1. 1, 7, 9. Yeah, here it's interesting. Yeah, probably it would not work. So I have 9. So if 5 is less than 9, I go here. Here it says 3. Here I have 1. Yeah, so idea is the following direction. Midpoint, if start greater than midpoint, I go left. Then, if start is less than midpoint and less than end, I go left. Yes, if start is less than midpoint and midpoint is greater than end, I go right. So this is actually the logic. So let's try to implement it. So I have left -1 and right, it would be num/slacks. All right. So while r minus l is greater than 1, I'm doing some logic. So I first try to find neat. Okay. Then what I'm checking. So now I have I have start point and midpoint. So I think that start. So start, it would be my nums l plus 1. And I'm checking if nums mid is less than start, or if nums mid is less than, for example, can I have a situation when this one is less? Yeah, so when this one is less than this one, I should go. Okay. So I'm checking 9 and with end. Yeah, so end would be and nums r plus 1 minus 1. Yeah. So in this case, now I also check so here I'm go where? I go to the left. So my mid would be equal, my R would be equal to mid, else my L would be equal to mid, and here I return, let's say, yeah, so I'm checking actually if L is equal to -1, I return nums rare, otherwise yeah, I can check like if L not equal to -1 and R is not equal to nums length, then I return minimum between nums L and nums R. Otherwise, I return L is equal to -1, I return nums R or nums L. Something like this. Submit. Okay, so here I return 4. Yeah, it's interesting. Let's take this test case. Okay, so let's check. So I have my mid, and in this case it's 1. I see start is greater, so I move 1 here. Okay, so I also think that when I'm moving something, yeah, I can here as well check if my previous value, for example, mid -1 is greater than nums mid, then I just return nums mid. And here as well. I think here it would be like if nums mid plus 1, it's like this. I think this one should work. No? Okay. Yeah. And yeah, I need to check if neet not equal to 0. Okay, so now it works. We see 100% bit. And so let's check solutions. Yeah, a lot of text. Binary tree. Java. Yep, this one as well. Interesting. All right, so yeah, so here we have binary search logic, and with this binary search, the main idea actually to understand where should we go. So when we are standing here, we can check first and end, and understand where should we go. So this is the main idea here. Thank you, and see you next time.